I've got a dam face, so try and draw myself a dam. Yeah, I've seen worse, I've seen better. Okay, so dam face, holding back water. So the dam is, how deep can the water be in the dam? We'll make it 15 metres deep, and we'll make the base of the dam that's blocking off 75 metres. So it's quite a big dam, so it's 75 metres wide, and it's holding back water to a depth of 15 metres. Okay. And we're going to try and figure out what's the force on the dam that's trying to move the dam. So that piece there, which will be 75 by 15, is the wetted area. That's the area which the water is pushing against. Yeah. So we're going to use force as pressure times area from before. And we're going to try and work out what the force on this dam is. The area is easy. The area is 15 by 75. So the area I'm comfortable with. 15 by 75. Why do I choose such stupid numbers to work with? 112 and a half. Someone better check that for me. I'm just making numbers up as I go along. Okay. Is that right? Yes, I've got 1125. Yep. So square meters. So that's the area of that the water's pushing against. So that's the area. So now we need to know what the pressure that the water's pushing against this area. So how are we going to work out that pressure? Okay, so we're using this formula, Liam. Pressure is rho g h. Yep. Okay, so Liam's saying 1,000 times 9.81 times 15. I'm not buying 15. Why don't I like 15? Because the lake, the pressure at the bottom, I agree, will be 15. What's the pressure at the top? How much water is it? Just right at the very top. How deep is the water at that point? 0. So the pressure at the top is 0. So the pressure at the bottom is due to the full 15 metres. Pressure at the top, nothing. So what figure am I going to use in this calculation? 7.5. Yep. So it's the average depth. So the H here has got to be the average depth. If we're trying to find out what the pressure on the surface is, on a vertical surface, then you've got to get the average depth. Well, because it's much bigger pressure at the bottom than it is at the top. So when you're looking at across this whole surface, it's not fair to say, well, it's the full 15, because it's not at the other points. So you've got to take an average pressure. So only 7.5 metres. And Scott's busy pushing some buttons on the calculator and going to tell me that it's equal to 73575. And that's in pascals, is it? Yeah. So we're talking about, say, 736 kPa. Kilopascals? Oh, 73.5. 0.6. Man, I did double mirror there. Rounded it wrong and put the decimal place in the wrong place. It's two things you could get wrong. I got them both wrong. Okay, so we know 73.6 kilopascals. So now we've worked out the wetted area and the average pressure. So we can use those two things to work out the force. So the average pressure, 73575, area 1125. Calculate that out, it's going to come out in flipping meganewtons or something. What do you got? 82.8, we'll call it meganewtons. Okay, so a lot of force on the side of a dam that big, and you've got to be able to push back with that amount of force. Yeah. And it's not something you're going to have to worry about in this course, but it is interesting to note that if we think about the pressure at the bottom, the pressure is this full 76 kilopascals, and at the top, the pressure is none. And we've sort of worked out, to work out the force, we've dealt with this average pressure. But if you think about it, then the pressure above that is smaller than the pressure below it. So we talk about the point of application. So it's to do with moments. So the problem with a dam is it's not going to go just slide along the bottom. It's actually going to overturn. So if you have a gate, it's kind of hard to imagine a whole dam overturning. If you think about a channel with a gate in it, and when the water pushes it, the water's not going to just push the whole gate back. It's going to flip it. It's going to turn it. And the point of application of that, because it's a triangle, is a third of the way up. And remember triangles from centres of area and things? So this would actually be 5 meters. So the overturning force, the overturning moment will be the force applied 5 meters from the base. And that'll give you how much turning moment your dam's got to be able to withstand. Okay, so the whole idea of moments comes in again, which is quite cool. But as far as this course is going to go, you could get a question that goes to this point, where you've got a vertical surface, you need to work out the area on the vertical surface, the average pressure, and then multiply the two to get the force on their side. It's not an unheard of question.